We are live. Welcome to an episode of, I don't think this is a series, but this is just Modules with Myles. I'm David East. You probably know that, but I have a very special guest right here.
Hi, I'm Modules. I'm Myles. I'm Myles Borins. I'm a developer advocate in the open source programs office at Google. I do a bunch of different stuff in the JavaScript ecosystem, including in the Node.js project, where I sit on the technical steering committee. And then I'm also leading the group that's doing the implementation of ECMAScript modules in Node.
So we are super, at least I am. I'm super blessed today to have Myles around because I am quite the neophyte when it comes to ES modules in Node. I have, taken advantage of Transpilation to do that for me for quite some time. But now I'm really excited that, that layer just kind of goes away and that we get to use pure modules in Node. And it's, as of Node 13, it's completely unflagged, which is a really, really cool, it's really cool. I'm a big fan. So I wrote a very, very simple Node module, and it's all in CommonJS right now. And then Myles is going to teach me how I can move that to ESM. So, and thank you everybody for the happy birthday stuff. This is
your birthday?
Yeah, that's see?
Like today?
Yeah, that's it.
Like right now?
Yeah, it's the first
time. Moment?
It's the first time in my entire life that my birthday isn't tax day.
I did not realize it was your birthday, and we've talked so much today. I feel terrible. Happy birthday.
It's okay. When as you get older, you don't care as much about your birthday.
Do you know when your birth time is?
I was born in a country that no longer exists, and so I'm not sure what the time zone is. And so actually, I like to play these games during this. So in the chat, if you want to guess how old I am, and because that's fun. That's a hard one for people. And if you want to guess what country I was born in, just let's figure it out. It no longer exists. It's a bit of a technicality, but it's still true. All right, so I'm gonna pull up my and my wife and kids did this. I'm not a bad artist and vain. Well, I'm a bad artist, but I'm not that vain.
I saw them earlier, and I just assumed it was like your birthday a while ago, and you just really love your kids a lot.
No, they did. Oh my gosh, Facundo, you did it again. That's another really good guess. So I'm gonna have to learn to say your name properly now because you have done such a great job. 60, thanks, James. With 21, thank you, Hussein. He guessed the T right on the last one, and yes, I'm 32 years old. That's that's good.
You're 2 to the 5. You're not going to have another 2 exponent birthday for a while.
Yeah. I'm okay with that. And not from Yugoslavia, Patrick. All right, so let's go into laptop mode. All right, here we are. So I'm going to walk you through the app, Myles, and for the rest of you in the audience. So let's learn how this app works. It's really simple, and then we're going to convert the CJS into, let me go back to index, CJS to ESM. So this right here is the entry point. It's index.js. I require this thing get app from cities, and this cities imports from Firebase. I could do the admin SDK. I just didn't want to download a service account and have that be exposed. So I figured that was probably a good idea. So I have this whole get app that pretty much checks to see if you have a default Firebase app. If you do, return that. If not, create a new one. And then within here, you pretty much, I get a list of cities or a single city, so collection document, and that is done as a, and this actually updates all the time, like every second or so. And then config.js is just my Firebase config. So that is all this is. So where should I begin, Myles, to start converting the CJS to ESM?
Well, the first thing we're going to want to do is we're going to change your index.js to index.mjs. So in Node, if you want to be writing modules, you need to use the MJS file extension, or alternatively, you can add into your package.json type module. If you do that, then you need to change your CommonJS files to be .cjs. So since we have a majority of CommonJS in the project right now, let's stick with MJS. The thing that's nice is .cjs will always be CommonJS, .mjs will always be ESM, no matter which mode you're in. So let's go one step at a time through it, and then like we could do some more refactoring later. But I would say, since we're only changing one file right now, it would be good to just use MJS.
Sounds good.
I tend to be explicit here, and so I've been pretty much using .mjs everywhere, and I don't really use type module. And I'm starting to use .cjs, but there's complexities, and we can get into that afterwards if we want. So now that you've done this, you're going to want to go and that const app, you're going to do import instead of const. You're going to change that require and that to from, and you're going to delete that. And let's try running it, but this isn't going to work. And there'll be two reasons why, and we can make it work afterwards.
It says cannot. Oh, well, of course, I need to change it to MJS. And by the way, MJS, correct me if I'm wrong, but it stands for Michael Jordan script, right?
It's actually Myles JavaScript.
Oh, Myles JavaScript. Okay, yes. There we go. So this is our, oops, whoa, what is going on?
So you can't find the Firestore module source cities imported from. So what this error is telling you is that from the cities, if we go to the main file, doesn't exist. In the ESM implementation of Node, we no longer have what we call the node resolution algorithm for specifiers. So that was what allowed you to not include file extensions or to require a directory that had an index. So the first thing that we can do here that's really easy is go back to your index.mjs file. And when you do from cities.js. This is important, and I know not everyone agrees with the decision here, but this is part of a goal that we have for browser equivalence. And we could dig more into what browser equivalence means later, because it doesn't mean that it is 100% compatible with the browser today, but it's that it can be. So file extension resolutions, as they work in Node, involve statting the file system from all the different potential file extensions that it may be. So it's actually a pretty inefficient algorithm. And if you have lots and lots of specifiers, it can actually be a major startup cost to your applications, which you can actually feel if you're running in a serverless environment where you've got cold starts that matter. So dropping this actually could improve performance in applications. But what this also means is in a browser, browsers are looking for like absolute or relative file paths, and they're just going to stat once over the network. So unless you had a smart server that was then statting the file system for all the different things that cities could be, because it could be .js, it could be .json, it could be .node, it could be a folder that has .index. That folder could have a package.json. That package.json could point to something else. There's a lot of different things. And if you go into the Node docs for modules, you can actually see the full algorithm and walk through it. But the browser is never going to do that. The browser is going to stat for a single file. So enforcing file extensions, but more accurately, enforcing full file paths is something that we've done in the ESM implementation of Node to kind of ensure that we're not doing things that will never be browser equivalent.
And that's nice, because there are times where I have actually, written like Webpack magic that will go through and rewrite these, or, replace the module so it can be used on browser and server or Node or browser. And so it's nice that that's just like one less layer of like tooling or magic I have to include into like a build step.
Yeah, and I think I really love the way that you call it magic, and magic can be great. I love magic, both like cards, Johnson, and in software. But like in general, magic, it can also be a barrier for interoperability and a barrier for education, because you have to learn it to understand what the magic does.
Exactly.
So let's try running this now. Spoiler alert, it's not going to work, but we're going to get a different error. So the requested module does not provide the export get app. So two things that we're seeing that are really interesting and cool here. One, you can import CommonJS and it works. Two, if you try to import CommonJS, you can't get named exports. There's a really, really long story about why we can't do it. The short answer is there's no way to do named exports from CommonJS modules while remaining spec compliant. CommonJS modules are synchronous with inline execution. ES module has a variety of different phases to it. We attempted at TC39 to standardize dynamic modules records, which would have allowed some of this to work, but it would have precluded the ability to do export star from module, and we couldn't build consensus that introducing the ability to do named exports from CommonJS was worth losing the ability to do export star. And it introduced a lot of edge cases. We haven't given up on trying to make it work, but a really quick fix that we can do here is if we go back to that file and instead we do import cities from cities. And now we can either destructure cities on the next line, or we could just call cities. So this should now work. It's not great, but let's see.
That for the people who don't know, that's correct. That's what we want to see.
So the next thing that we may want to do is go into cities and convert that to ESM now as well.
So I would change that to MJS.
Yep.
All right, Myles JavaScript.
And now we're going to go and we're going to change those to import statements. What's really cool is these are both still CommonJS modules, but because we weren't doing named exports on either of these, we're not going to have any problems with importing them.
Right, because Firebase, this is get rid of those, but this is Firebase is currently, I believe the Node version will be all in CJS, and then this is a just a module that exports. So yeah, These are two CommonJS files.
And then just at the bottom where it's module that exports, we're going to want to delete module there and leave exports. And we're going to delete the equal sign and make it export. And this should work now.
All right. It's kind of nuts. That was not a lot of changes. I mean, this is simple, but it's still not a lot of changes. Oh, we got an error. I like it when we
not find module cities. Oh,
that's right.
Well, let's do something here really quickly.
Yeah.
Let's change config to .cjs.
That's what I was just thinking, yeah. All right, so you have a CJS file.
And let's change cities and index to be .js.
Cities and index to be, oh, yes. And
let's change cities to JS.
Okay.
And leave index as MJS.
Okay, just for like explicit.
Just to show that we can do the different things. And let's go to the package JSON, and we'll add type module. Right. So now let's try it. This should work.
Let's go. Oh, wait. Oh, because we are, wow, this is actually, the great thing is this isn't working, but I understand why it's not working.
Yeah, so let's go and add back that named export that we were doing before.
Yeah, this is what we want. That's really cool. Like, there we go. And so now we don't need that anymore.
Yep.
Boom, that works.
And there we go. We've now converted the whole module to ESM.
And that's cool because we've converted it. But what I initially thought when I saw like all the blog posts and the news about Node 13 having unflagged modules is that it was going to be, I don't want to say significant, but there was going to be some rewrite, and that any type of interop between CJS and, ESM was going to be like fairly difficult. But it's really cool that we have literally 3 file extensions living in harmony with each other in different ways to match them together.
Mm-hmm. It's pretty cool. And there's a couple other features under the hood that are pretty interesting as well that I really like that maybe we can explore right now. So
yes.
For example, we're doing get_app from cities, but we need to do .cities.js, which maybe we want to do, maybe we don't want to do. Let's add an exports map and do some cool stuff here. So if we open the package JSON here, and so the name is Firestore module. Do you want to change the name of it, or do you want to keep it as Firestore module? Let's do something short so it's just easier to write.
It's called this weather fire because weather fire. We're good. Yeah.
Okay. And then you'll notice that we have a main here, but let's make a new item in the package JSON called exports. And that exports is going to be an object. So what we're doing here is we're making a package export map This is a new feature in Node. It is unflagged on 12 and 13 as of 12.16, I believe. It can be used in all of the 13 line of Node after 13.2, I believe. But if you're using the latest versions of 13 or 12, exports will be respected. We're going to want to make a dot export. So you're going to, in quotes, add a dot, and you're going to just make that source /index.mjs. It will have to be /source. That will actually fail without the /. We're enforcing a little bit more rigor here. And then what the dot export is the equivalent to the main. So you can actually delete the main now. But the thing that's kind of cool, and this is a feature that you can use, and we'll show a package later that has legacy support. If a version of Node doesn't support exports, it will still look at the main. So you can use the main as a legacy fallback for versions of Node that doesn't support exports. So this is like some new patterns that you're going to see starting to come out for module authors about like, so we have that index.mjs right now. Well, maybe you wanted to transpile that to common.js and expose it as index.js and have like a legacy entry point that people can use. Now, we're not really building a module that's consumed as a library right now, so it doesn't make perfect sense to dig too much into that. But when we examine the module later, we'll see a little bit more about why you would not want to do this. So the next thing that we're going to want to do is make a named export. So the other thing that exports does that's pretty cool is it locks down what people can require or import from your module. So traditionally with modules, you're able to like require the module and then do / and then like kind of deeply go into the module. And this is a programming pattern that we've seen used quite a lot. It's great. Lodash is a really great example where you like require Lodash /fp, and then you get like a whole bunch of functional programming primitives. The problem with this is there's really no such thing as like a public and private interface when you're exporting things like this. So you end up exposing every single file in your entire module, which may include things that you don't want being part of your public contract for consumers. So when you use exports, by default, it actually locks down everything. So now when someone requires or imports this module in a version of Node that supports exports, it will fail on anything but the main now. So if we wanted to offer legacy support, so let's say you wanted to add exports to a module but still remain Semper compliant, let's make a new entry in the exports map, because you can also map directories. So do // and map it to /. That is all you need to do for legacy compatibility. But where this starts getting really cool is, let's say you wanted to have like module /util / a whole bunch of utilities. You can map that to anything, even if util was a directory in source. You could do source /util. So for right now, let's say we wanted to expose the config, right? So do /config. Replace the // because we're not going to need it. Do /config and map that to /source /config /cjs. So now we're going to use another feature that's super cool called self-referential modules. So go into cities, and instead of /config.cjs, import from weatherfire /config. No extension. Now try running it.
Boom, works.
So there are so many cool things that just happened right now that make me super excited and I want to dig into. So one of them, you're inside of your module and you're importing yourself.
That's fresh.
It is so cool. And there's a handful of different things that's important. One is we've made a public interface here. So if you don't want config to be something that's exposed to people consuming your module, you won't want to do this. But where this becomes really important is, and it was a challenge that we had when we were designing export maps, was how do we actually test that interface? So if you're defining all the different interfaces of your module in the export map, how do we even test that? So you're actually now in your tests able to test the public interface of your module using the exact same interface that all your consumers use. So if you're writing end-to-end tests, you can actually just like grab the module and be limited to the interface. That doesn't stop you from still deeply going in and grabbing individual files. The other place where this is super awesome is for examples. And I'll show that later, but now you can have examples. Those examples can live inside of your folder, can use the exact syntax that people can copy and paste into their file. And you don't need to have like a ./source/index that you tell people in a comment replace. Like that was a really gross pattern. Or alternatively, have examples that can't actually run. Or, and I've done this before, have like a dev dependency that references yourself that installs like a symlink to your, like there's really gross patterns that people have done before. This is all now built directly into the loader. And I want to call back to something that was really important that we mentioned before, which was web equivalence. So what we're looking at here is like a whole new pattern for creating shorthand, for creating like ways of referencing things that didn't exist before, but also technically at face value doesn't look like it would be compatible with the browser, because the browser is not going to know what even from Firebase means. So how are we even supporting bare imports, as that's what it's known as? And there's a standard that's being worked on in YCG, which is the Web Incubator Community Group, which is part of the W3C, called import maps. And import maps will be it's a JSON-like format that can be used for defining bare imports and what file paths they reference. And so at a high level, what this would allow you to do in a future world where people have export maps everywhere is npm install a module. And if all of your specifiers are compliant to your export map and you have a single export map at the top of your project in the package JSON, an installation tool will be able to statically determine every single potential specifier that's referenced throughout your entire module graph, including nested dependencies, convert that into an import map. And then you'd be able to inline that import map into the browser. And there's another feature that we have that we haven't dug into yet that we'll look at a little later, called conditional exports, that allows you to define, if we go back to the package JSON for a second, we could say that for ./config, we could actually have a different, or for the .import, we can have a different .import for require and for default or for import. So you can set like, hey, if I'm importing this, serve this file path. If I'm requiring it, serve this file path. And you can add any entry you want into a conditional export, and Node will just ignore it if it's one we don't know about. But that makes this format something that's extensible and something that tools in the ecosystem can build on top of. So you can make a browser entry in there, or like a React Native entry in there, or whatever tool, Electron, for example. And the whole idea would be that at install time, we'd be able to statically derive an import map for whatever environment you're targeting. We still need a bunch of tools in order to kind of get to that future that I'm painting here. But the biggest difference, and the thing I'm most excited about, is that this is all static as opposed to dynamic. Mm-hmm. In the classic require algorithm, the classic Node CommonJS algorithm, it is a dynamic algorithm. Your specifiers, we don't know what it is. We at runtime need to ping the file system or do certain operations to figure out what it is. This new system is completely static, so we can crawl the file system and know what every single specifier may potentially be. If we were to put like our computer science interview hat on for a second, we took something that was order n and made it order 1, and potentially even order n squared, or even larger if you're considering that like module graphs explode in infinite complexity. And we took that whole thing and made it order 1. Which is really, really cool. And I think we'll actually see a whole bunch of improvements in performance, as I was mentioning before. But extensibility is really cool as well. And I think there are tools out there like Pika, the Pika package manager, for example, which is doing some interesting work around like, hey, let's like transpile your whole thing at install time. But they've also done experiments with building import maps and looking like, hey, well, maybe we don't even need to transpile anything, as long as people kind of like pre-transpile and serve their assets this way. And the hope would be also that with this extensibility, any number of tools could be built that could kind of build on top of this export map format.
And I'm a huge fan of the self-referential modules, because whenever I do tests, I actually will npm pack the library and then create an entire like sub package that depends on that, and then install that through CI and then run the test. So I know that it's like hermetically the same thing that, that the developer would actually be doing. So having these self-referential modules that just handle that without all of that, all that goop is really good, because it really does, between the pack and the installs, it really adds a lot of time onto the CI process. So I'm very excited about that.
Yeah, I guess the one thing I would say in regards to the goop that you were describing, like it sounds like the npm pack test pipeline there may still be useful, mostly because like npm itself has metadata that it looks at, such as like npm ignore files or like includes that like you could break things, but that could be more of like a CI/CD pipeline that's like, let's run the test once before publish or something like that, as opposed to something that needs to be run every single time you run your test suite locally.
Right. Addressing some of the questions we have here, which, by the way, I'm not from Czechoslovakia. But Luke Edwards has a question where he says, self-referentials that can't support legacy interrupts, right?
I'm not sure if I'm 100% following, but I think I am. So self-referential modules can work in both ESM and CommonJS. If you want to make a new CommonJS file really quickly, like test.cjs, we can show that you can require weatherfile /config, and it will still work.
All right, so import
const config equals
/config.
Oh, you're going to want to do weatherfire /config.
Oh, I see.
I just wanted to show that this works in ESM, and then maybe console log config.
Yes, let's do that, and I'll just run a node script to do that. So node source /test.cjs. Yeah.
And then do you have NVM or a node version manager installed by any chance?
I do.
So do you want to switch to node 12 really quickly?
Is 12.14.1 good for you?
No, you're going to want to update your node. So I'll show this later in my examples. But here you can see that it does work in CommonJS. If by legacy interrupts you meant older fallback versions of Node, older versions of Node that don't support export maps do not support self-referential modules, and it's not something that we're going to be able to support. But with that whole main entry point that I was talking about there, I'm not sure if tools like Rollup, for example, support self-referential modules yet, but it's a matter of time. Guy Bedford worked on this stuff with us. Let's say we're living in a world where like Babel and Webpack and Rollup and all these tools are aware of self-referential modules. You would be able to transpile a legacy version of your module that you would put in the main, and that would transpile out the self-referential module as part of it.
All right, that's I mean, this is all very fresh and new, so it's really cool that it just exists.
One of the things that's pretty exciting though is the implementation that's in Node 12 is at least supposed to be, and if it's not, please open a bug and we'll fix it. But to the best of our knowledge is equivalent to the implementation in 13, aside from the fact that it still has the experimental modules flag. In Node 12.17, which is slated to go out in, so as of Node 12.16, Søren, to answer your question, we support self-referential modules in 12. But as of Node 12.17, we'll be dropping, 17 is not out yet, but when Node 12.17 comes out, we'll be dropping the flag, is the current plan. So, but yeah, if we use this really quickly, you'll have to do Node experimental modules.
Right.
And we can just show really quickly with the experimental modules flag on the index, and it should just work.
And that will be, so you want me to run it on index?
Yeah, run the index first to just show that the module works. And then let's go up and try it on test. And test should work as well. And that was test CJS.
Oh, I think it's because it's CJS. That's why. I was like, I'm pretty sure I did something wrong. All right. Yep, and that works.
Yeah. So in Node 12.16, as I mentioned, all these features work. There's a few more experimental warnings. You'll notice that there's a package self-resolution warning that's still showing up in Node 12. We should drop that. I think that warning's not on 13 right now, but they are feature equivalent, which I think is the most important part, aside from that one flag.
Awesome. That is that's cool. I think the exports map is having conditional exports, having being able to do self-referential, all those things. That is very exciting for the future of JavaScript packaging.
I absolutely agree. And I'd like to do a quick shout out to like a handful. Actually, you know what? I will just say the Node modules team, because it's maybe not fair to just say the few people whose names I think about right now. But one person in particular, Jan Krems, was one of the people who really helped push the idea of these export maps. And I'm beyond grateful. And export maps and conditional exports in particular ended up being the solution that we have to dual mode modules. And maybe that's a great segue that we could do to me taking over and driving for a minute and showing a dual mode package that I have.
Yes. So yeah, now we went through the basics of just taking a CJS and learning about interop, changing things to ESM. But Myles has a package that he maintains and has maintained for almost a decade now that he can which has a great story behind it, because it is pretty much how Myles went from one career to where he is sitting now next to his Peloton. Sorry, I had to call that. I mean, sorry, what Peloton?
And one of the things that's cool is that back here, I've got the hardware music device that actually got me started in all of this stuff called the Mono, which the Mono uses OSC, Open Sound Control, to communicate. And that's what got me into Open Sound Control. And I was in art school, and I was building an art installation where I was hacking with the Connect, and someone built this this utility, which may even still work with the old Connect, called OS Skeleton. And what OS Skeleton did was it took the Connect metadata for skeleton tracking. You had to install a whole bunch of and compile a whole bunch of natural interface stuff, but this is how to hack the Connect 10 years ago, and it would turn it into OSC messages. OSC is kind of like MIDI, and the thing that's really cool with MIDI, with OSC instead of MIDI, is MIDI you're kind of limited to a granularity of 128 messages, and you need to go over a MIDI bus. UDP can use a whole bunch of different backends. OSC can use a whole bunch of backends, but by default it's using UDP over your local network connection. So it just kind of fires messages out over UDP. So when you plug in the Mono and you run the driver and you press a button, it sends a UDP message that's encoded using Open Sound Control on the local host on a port that you define. And the message has encoded the X and Y coordinate, and a 1 when you press it, and a 0 when you let go. And then it also has an OSC server that's running that you can send a message to with an X and Y coordinate, with a 1 for on and a 0 for off to turn the lights on and off. And with that very, very slim programming interface, you can build extremely complex and really interesting interfaces. But Open Sound Control also ends up becoming this kind of not exactly standard, but consistent communication protocol between a variety of different musical tools and tools that artists use to build installations. So while Node OSC does not get a ton of usage, I do get emails once in a while from wild art installations that are 1,000 feet tall with hundreds and thousands of LEDs, where they're using this as the backbone of the communication protocol, which is really cool. And so I was building this installation, and I wanted to be able to control the messages and change the installation with a phone application, because I love non-native solutions. And I couldn't figure out for the life of me how to turn a WebSocket message into an OSC message. I tried with PHP and couldn't get it to work, and I tried with Python and couldn't get it to work, and I found this library called Node.OSC, which also didn't work, but I knew enough JavaScript to like make it work in about half an hour. And that was actually the first thing I ever did with Node. And I ended up turning it into a module, because back then NPM was like this thing that not a lot of people used, and they had like a Google group. And so if you actually look it up, you can find a message from me from like 2009 where I'm like, hey, all, oh no, 2010 or 11, where I'm like, hey, all, like I just published my first module. Tell me all about it. And like I joined the IRC channel, and that's where like I met Nexi. Anyways, let's not get too much into like all of that fun story. Let me share my screen, and I could show the module. But this is a module that has a fairly slim interface. I've been maintaining it for years. It doesn't have a ton of people who rely on it, so if I break it, it's not the end of the world. But I've been using this module as a way to like introduce experimental ESM support and kind of work through the process of like what we went through with David was like, as a programmer in Node who's consuming modules, how do I work with different kinds of modules? How do I consume them? How do I work with them? But the other thing that's really important is, how do I do this as a module author? So let me get my screen shared here. Can you see my screen?
I think I need to add you. Now we're good.
Cool. And I probably need to enhance.
Computer enhance.
Okay, so I've enhanced that, and I've enhanced that. Okay, let's see if it looks good.
There we go.
Okay. So this is Node.OSC, and you can notice a couple things that are going on right now. It's already had implemented support, both fallback support for old versions of Node that don't support exports with the main field here. It has two entry points as the import. It has an import and it has a default. And I'll show you in a minute. I can change that to require. That was actually a hack to avoid some warnings. That's no longer a problem. You'll notice I have the / to / export, which is not something we actually advise a lot of people doing, but it is an important way of consistently having legacy support. So a big thing that I think is really important is Semver and the signal that you give to the consumers of your module. And the interface that you have is really important to be consistent with. So if you introduced exports into a Semver minor or a Semver patch of your module and didn't include this line, you are potentially breaking people who are deeply searching into your module. And we also have a .esm entry point, and that's actually I'll fall back to an old version of interoperability that we had, but since I added it, I can't remove it until the next major version of Node. Looks like we have a question, so I'll stop really quickly. 12.16 supports ESM and self-referential kind of flag will show warnings. 12.17 and 13 support ESM and self-referential without a flag will not show warnings, right? So 12.17 is not out yet. When it does come out, it will have no flag. Both 12.17 and 13 still have warnings though. Modules is still experimental. We're in the process of figuring out when we would remove the warning. But even when we remove the warning, we're probably not going to stabilize it. At least, like we're trying to get the warnings gone in time for Node 14 moving to LTS in October. And I think we would like to see the warning removed by then as well. But the part of the challenge here is that, you know, the warnings that we have make it really clear, in the same way that the flag did, about the levels of support that we're offering, as well as the possibility that things can break. So we're kind of rolling this out as a waterfall and trying to ensure that, like, hey, we're going to slowly make this easier and easier for people to adopt. And as we expand the group of people who are adopting it, we're getting more feedback. And it's possible that some of the decisions that we've made, either through the export maps or through self-referential modules or with type module, like there's a bunch of different things that we've done that may break people. And so we need to allow ourselves the ability to change or break behavior that is currently locked into the implementation if we find out that there's a really, really major problem that we were unaware of or unsure of when we first did it. So it's kind of like a really great example of this is, like, at one point we actually allowed this, but we actually require the / now. It's a very, very tiny change, but was really important for us to handle. Also, import at one point was called module, but we changed that. So that was part of the reason why we kept an extra warning, which you still see in 12 for conditional exports. And I think there's even a pull request open right now that slightly changes some of the behavior for error cases that we introduce in exports. Basically, another thing to keep in mind with node semver policy that we have, when things are experimental, we can do semver major changes in a non-semver major release because we don't consider them semver major. It's part of our contract. Now, with that being said, each time we kind of take a step forward to things being stable. So like, well, things are behind a flag, we'll do whatever the heck we want. So one of the reasons to keep modules behind a flag in 12 longer than 13 was that 12 is LTS. If we want to do semver minor changes, so like add new features to modules, if we remove the flag, in theory, we would maybe need to land those as semver minor. Breaking changes, we potentially have to land as semver major. But because it's still behind a flag, with each semver patch, we can keep it up to date with 13. And the fact that we have the flag is kind of a clear signal to people like, hey, this is not production ready. We're going to probably break stuff. When we remove the flag, that is kind of a signal to folks to say, hey, it's way less likely that we're going to break things in between patch releases. And in LTS, we only do one release, we generally only do one semver minor a quarter. And with the current global situation around COVID, we've actually delayed some of those semver minor releases to ensure that people have more time to prepare and less inconsistencies and potential breakages. Because 12.16 actually broke a bunch of stuff, and we had to do a bunch of last-minute fixes to catch stuff that we just didn't catch in testing and weren't aware of when we backported things.
We have a really important question. Jeff Cross said he just got here, and he asked us if we could start over. So we're just going to have to take it from the top.
Well, Jeff, you're really lucky because I've just been yapping for a bit, and I haven't even really started digging in here. So we are kind of, in a way, starting over.
Yeah, there you go. I like that. That philosophically, I like the way you think.
So let's start over right now. So one of the new features that we have in ESM is this package exports field. And one of the features in package exports is this idea of conditional exports. So where in old versions of Node, you would have used a main, in ESM and CommonJS in Node 12.16 and further, or Node 13, you can introduce this thing called a dot export. And you can do these conditional exports that allow you to specify, hey, if I'm importing something, use that entry point, or if I'm requiring something, use this entry point. Or I say default here because the default of this package is CommonJS. You can also map directories. So this // to / directory mapping here allows you to continue to require module and deeply traverse into the file system. But if you didn't have this, you wouldn't be able to deeply traverse into the file system for anything that isn't explicitly inside of the export map, which we can see we have an ESM entry point. Now you'll notice that I have two entry points for the dot here, as well as a main. The reason I've kept the main is for a fallback. So if you're using a version of Node that doesn't support export maps, you'll still get the main. If you're using a version of Node that supports export maps, you'll get the dot export. If you're in ESM, or if you import or dynamically import a module, you're going to get this path. If you require a module, you're going to get this path. So let's look at those two paths and see what they are. So if we go here into lib and we look at index.js, it's a CommonJS module. I've got three classes called message, client, and server. Here's message, here's client, and here's server. And I'm just requiring them, and then I'm exporting them. That's a pattern I like to do where like I kind of have everything teased apart. And then you'll see the ESM implementation here. Oh, that looks really similar. And the reason why we have to do this is that to remain spec compliant to the ECMAScript specification, we cannot do named exports from CommonJS modules. So if you want to have a module that's dual mode in that it supports both import and require, and supports named exports from its ESM interface, you need to do a combination. It's a CommonJS module of a wrapper that names the exports manually, and you need to have an entry point into your export map that specifies the inputs. So now let's look here in the examples folder, because this can help us. Let's make sure we're using the right version of Node. We're using 13. And so we can go here and we can see, hey, we have a server here, right? And we have a client. Those are like the two versions that we can have. So let's open up two things. Let's enhance. Let's run, let's use the example here, and we'll run the server. And we'll do the examples here, and we'll run the client. The client sent a message, and the server received it. Now, one of the things that we should be able to do here, that's pretty cool, is we should be able to actually use self-referential modules here. And we should be able to change those to just be referencing the module itself. Let's run the server again. It still works. Let's run the client here, and you can see it still just worked. So this is another feature here, Jeffrey, back to the basics again, called self-referential modules. You're able to reference modules within the module itself using the specifier. So this module is called Node.osc. So if I require or import Node.osc from within Node.osc, it will reference this export map. So let's look at the ESM implementation here, where you can see we're importing the client and the server, and it's more or less the same code, just in one file, and it just works. And just to kind of show a little bit more about how self-reference works, you could see that I have this reference ./ESM, which references the exact same file. It still worked exactly the way that we expected it to. So all this is really great and useful if you've got a common JS module that you want to offer an ESM, like an ESM interface for. If we didn't have that interface, people would have to import your module with only the default export, and then on a separate line, destructure that. So if, for example, we got rid of this, and we went and we tried to run this file right here, again, it's going to fail, and it's going to say it doesn't provide a default export named client. And we'd have to basically do this. And now it would work. So you can import common JS modules, and they will work, but they only have a default export, and you need to do that the destructuring in a separate line, which is actually, I find a really interesting throwback to, like, a lot of people started using ESM because they loved destructuring, even though they called it named exports. And they talked a lot about this idea of tree shaking and all these fun things. But the way that Babel originally implemented ESM was essentially just changing this line to be and if you had this line, it just did this. And that works because destructuring works. And if you were running in an environment that didn't yet support destructuring, then they transpiled out the destructuring. But like, to me, that was always like a really interesting one for me, because a lot of people were like early adopters of ESM, almost entirely, in my personal opinion, because they love that syntax. But you know, that's speculative.
An interesting question we have from Vikram, shout out to Angular Universal, is do we still need to use .njs file extension for entries in the import path of the conditional export? So in the package export map, for any entry in the map, you need to use the full file path. We do not do so that's true for ESM as well. So anytime you import anything in Node, you need the full file path. We don't do the Node.js resolution algorithm. The same is true for in the map. If we deleted, let's do the default here, because common JS is probably where you'd expect it to work. And it's possible. It's possible that this will work, but it's not supposed to. Okay, so this works right now, but we're removing this is actually a great example of why we have all of these features. And like when we talked about like the thing still being behind a flag, this is actually an example of something that we're changing. You should not be, you need to include the file extension here in the map. And part of the reason for that is so that we can generate import maps from it. The export map is supposed to be totally static.
It can be a .js extension. It can be a .mjs extension. It can be a .cjs extension. If you want to use .js for modules, you just need to add the type module inside of your package JSON. I personally like MJS, so I just do that, but there's no reason why you don't need to. And so looking at the questions here, why in the index do I export twice? In the export here, I've got a default export and the export of the individual named exports. Now I have another version of this module that's completely converted to ESM. And in that one, I actually dropped the default. This was actually needed to be there for legacy reasons because even a type module is not set. So Vikram, you can use .js in the map. This is separate. So if you said import and then set .js here, it will import, and when you import something, it will point to the common JS module, and it will still be interpreted by the node interpreter as common JS. So we can do this, and then we can once again run examples ESM, and now you're going to actually see that doesn't have the named export error. So yes, when we import things, it will use that entry point, but it will interpret that as common JS. What file extensions are interpreted as, like what modes they're interpreted as, are consistent no matter what. If you're in a type common JS, .js and .cjs are common JS, and .mjs is ESM. If you're in type module, then .js and .mjs are ESM, and .cjs is common JS. So I wanted to show something really quickly before we run out of time, which is the next branch here. So in next, I've converted the entire module to ESM. As you can see to the question earlier, I no longer have a default export. I only have the named exports. Everything has been moved to ESM, which is super fun. If we look back at the package JSON, we can see a couple things that I think are cool. One is we now have a main, and the main is ./dis/bundle. So we're actually using rollup to transpile the ESM module to common JS for legacy support. We've got a default entry point, and I'm using ESM as the default instead of common JS as the default because it's an ESM package. But we've also got that require entry point of ./dis/bundle. You'll notice that I only have named like one export entry here. That's a shorthand. This is equivalent to this. But if you only have the dot entry in your exports map, here's some sugar that you can use that you're just naming essentially the main. And in fact, you can even do, if we wanted to, that. If we only had a single dot exports and it was only the single type. So let's just get rid of that. Another thing you'll notice here that is super cool is you'll notice I'm using a utility called C8. And this is fun. I'm using tap with no coverage and no ESM for running the tests because tap uses J Dalton's ESM module for running tests on ESM. So if you try to use tap to run ESM tests, it actually runs them as common JS with J Dalton's ESM module, not with Node's native ESM support. That may have changed since I wrote this, but at the time that was true. So I actually had to use --no ESM to skip the legacy support that's in there. The other thing I had to do is add no coverage because TAP uses NYC by default. NYC uses Istanbul by default, and Istanbul doesn't have support for ESM because the ESM cache is not hackable, not touchable. The way in which code coverage has traditionally been done can't work. But the genius that is Ben Ko, who also created NYC, worked on this utility called C8. He worked on with the V8 team on first-class support for code coverage natively inside of V8. So at a bytecode level, V8 adds the code coverage into the bytecode before running it. And similar to NYC, if you just run the C8 in front of your test suite, it will just do coverage. So what we're about to see right now when I run test is it's using rollup, it's building a CJS version of the module, it's going through, it's running the test suite across my entire code base, including the bundle, and I've got 100% native test coverage across my entire library and 71% test coverage across my legacy library, which I don't even need to do. And here's the test in CJS, here's the test in Common. And just for example, the kind of patterns you'll notice is because tap is still written in Common.js and destructuring is kind of gross, I actually just abstracted that into an ESM module where I import tap, I destructure it, and then I export the things that I actually want to have access to. And then throughout my whole thing now, I can just import test from util. The other thing that I think is pretty cool to look at, so if we go back to the current release and we run tests, notice how much slower this is? So this was 3 seconds to run the test suite, and it didn't transpile anything. Let's go back to next. So this is with fully transpiling the entire library. It took a second.
Yeah.
So, what I'm hoping people see here are patterns that you can use for dual mode modules that people can both require and import, patterns that you can use if you're writing a Common.js module and you want to offer ESM support and do so in a way that's Semver minor, so you don't have to drop support. You'll notice here this version only supports node 12 and higher, and I think that I can actually get this to node 10 with a little bit of work. But if we check out the current release line, you can see that this actually still supports all the way to 8. I'm a strong believer that dropping support for a major version of Node is a Semver major change as a module author. And the patterns that I've done here, well, maybe not best practices, such as exporting .. and .. because it breaks that private contract. They do allow you to introduce ESM support to your modules in a Semver minor way. So here is how to do kind of future-proofing, and here is how to do legacy support. This module is on GitHub. It's github.com/MylesBorins/node-osc. There's a current branch and a next branch. You can look at those two to kind of see these two different examples. This is still a work in progress. I'm still learning as I go. We're still making changes and kind of determining what the best practices are. But at least in my personal opinion, this is one of the better examples that exists online for writing modern dual mode modules in Node that support basically every major version of Node that is still supported by the Node.js project.
That was quite the knowledge drop, man. We've met 2 or 3 times before doing this, and every time I'm like, oh, I'm starting to get the hang of this. And then even this time around, I was like, things were just clicking, and I was like, usually I'm like always getting chatty in these things, but I'm just like was intently focused because I'm single threaded. So I was like, oh, I'm learning so much right now. So I was like a bad host because I was like, no, I need to hear these things.
Hopefully some of those thoughts are just working in the background asynchronously and they'll resolve later.
Right, exactly. Yeah.
But if anything rejects, just how to get me.
Yeah.
One thing I would also add that I didn't mention is check the docs. The docs for Node are really great. And if things don't make sense, we would love contributions. Tech writing is one of the most underappreciated, most important bits of engineering. If people don't know how to use your stuff, it doesn't exist. But there's a handful of edge cases to dual mode modules, especially if you're writing front-end code or things like React and doing server-side rendering. There's a lot of weird things that can happen when you have multiple singletons sharing a single specifier. And we document like ways to avoid what we call the dual package specifier. I forget the name of it. We have a fancy name for
dual package hazard.
Yeah, the dual package hazard. Where essentially, and you may have dealt with this before, back before NPM started flattening modules, but if you require something and import something, they're in different caches. So if you import something first, it's going to get the ESM module. And then if you later import a common JS module that then requires the same specifier, that module will get a common JS version of it. And it will be two different instances of the same module in two different caches with the same specifier. And if you're using something like React, for example, then like it's going to be really bad because you're actually going to have two different render graphs that you're registering things in. For my module Node.OC, it's more of like a factory, it like exports factory classes for just like creating methods. So I don't have to worry about that hazard. But if you are running projects that may find themselves in that mode, you could do something like create a custom internal symbol, check against the global and put an instance of what you're instantiating on the global with that symbol, and then like serve that through the single. Anyways, we talk about it in there. There's patterns that are more advanced. I think for the majority of use cases, you'll probably be fine, but it's really good to like read the docs and get up to date on kind of where the foot guns are, because there definitely are foot guns.
Hey, as JS devs, we're used to loading multiple versions of React in the browser. It's about time we load multiple versions on the server. So just got to keep up that tradition.
Absolutely.
All right. Well, thank you so much, Myles. That was amazing. I was fully just knowledge dropped that I feel confident and capable moving forward with ES modules on Node. So thank you all for joining. And I don't know when my next, actually in less than an hour, Sarah Robinson and I are going to do tea time, where we're going to talk about early Firebase stories. This is why I got this shirt on. So if you want to hear all about that and have some tea with us, and my tea was guessed, so I have to drink a new tea.
So give my best to Sarah. We used to sit next to each other for a little bit in the New York office. And we just missed all working in the same office, literally when I worked for Famous. So that's a fun thing. You can
yeah, that's right. Yeah. That's right. That's another thing, is Firebase and Famous used to be office buddies.
Yeah. We can't avoid each other, it seems like. I unfortunately need to run because I'm actually late to my next thing. But thank you so much for having me. And if anyone have any other questions, you can hit me up on Twitter. If you want to get involved, github.com/nodejs/modules is where the team collaborates. And, we're always grateful for any work that people can do, or, feedback that we can get.
All right. Thank you all so much for coming out. We'll see you sometime later. Thank you to Myles.